Hello everyone, let's talk about Lecture 20, Causality. I'm your instructor, Miss Laura Lowe. We are in Module 8, Week 8. So you can see after we finish this week's lecture, then you will have your midterm exam. The midterm exam will cover from Module 1 to Week 8. And this week we cover only 2 lectures. Today we talk about causality, so we talk about randomized control experiment. So next lecture we will talk about the p-value sometimes has error. Then we will provide more example. So the final lecture, actually we didn't cover more new stuff. We will do some midterm review to help you to prepare for your midterm exam. Midterm exam will be on Monday in week 9. In the past week, we talked about different examples to demonstrate the hypothesis testing. So this slide, I also already covered at the end of lecture 19. So please make sure you review again and make sure you understand from different examples we provide you. So in the future, when you see a different number of categories, and also when you have the numerical data or category data, so when we have the hypothesis testing, how you will choose your test statistic and also how you do the simulation. So the step always the same. You choose the test statistic, then make sure you simulate many times. Then according to your simulation result, we graph our empirical distribution diagram. Then we compare the observed data with our empirical distribution from the simulation. So I won't repeat again. So if you forgot some of that, you can go back to the recording in the last video from lecture 19. But one thing I do want to talk about is in lecture 19, we have the new example we show is we have 2 group sample data. So that's our example about the newborn weight with the smoker and non-smoker. So from there, actually we only have our sample data. We don't have our population data. So in order to do our simulation, we need to do the permutation according to our sample data. So then we can just do the shuffling to reproduce, using the permutation to reproduce many sets of the data set. So we can perform our simulation. So this one is our A/B testing. So we have 2 sample data. So we will do the hypothesis testing. We say that's A/B testing. So let's quick do the review from what we have at the end of last week. So here we just want to show you again. So we compare 2 sample data. So we want to, our hypothesis is these 2 samples, their distribution will be the same as the population. So the alternative is they do have some difference. Like our smoker, the newborn baby example, our alternative viewpoint is the baby weight from the smoker will be less weight than the non-smoker. So then here we define a function we call the difference of mean. So since we have 2 data, we have 2 groups, so then we just calculate the difference from the mean from these 2 groups. So if you remember in this function, we pass in 3 arguments. So the first argument is your table. So your table, you have multiple numerical data or categorical data. But then the second argument, according to the numerical data attribute you are interested about, so then we pass in the numerical label. So then since we have 2 samples, so that's why here the group label will be the category on the column label for that. So after we have that, so according to our table, So then we can have our new table only have the numerical label according to different group. So then we have our, we've just find their average. So we just find their average. So we have average, so the mean table, including two different groups. So then here we have our column we choose is we only according to that average we get from the numerical data. So then we only get that column. So that's our means array. So then we can subtract from each other. So just here, you just remember this one is we're using the second group minus the first group. So I have to run this one again. So make sure you run this one again because these two functions, even we use for our A/B testing, but we need to use that for today's lecture as well. So after you have your difference from your two mean, the most important thing we want to do the simulation. So remember in the A/B testing, we do the simulation is we're using the original table. Okay, so according to the group label, so we reshuffle, or you can say permutation. We just rearrange the label, the group for each row or each data entrant. So it's the same thing for this simulation. You have three arguments. The first argument is the table name. The second one is the numerical data we are interested about. So then the third one will be the group label. So after we got that, so here let's do the permutation. Okay, so this permutation is according to the group label we shuffle. So that's what we call the shuffle label. So using your table, okay, so we still call sample function, but this sample function do not specify your sample size. So that means they will use the whole sample. Just make sure you have the with replacement equal to false. So that's why we will have every row have the they will cover for each row the value they will be select once. So then won't repeat. So then here after we get that, so then we just got that column. After you create that, we just using that column group. So then we got the label. So here it's just an array. So array contains the reshuffle. Each attribute, each row they have different group. So that here after we have that, that's combined with our numerical data. So then we add only the shuffle result. So we shuffle label. Then here is your shuffled label array. So that's we have our new table. So this new table, shuffle table, you have your numerical data and your shuffle label. So here, right, so we passing the table back to the previous function we have. So then we can find the mean, the difference of the mean from the two group. But of course, this one is from the simulation result. Okay, so again, the same thing. This one is what we want. Okay, so I run again. So if you remember this example we used for our baby example. Okay, so here our newborn baby example, then we just want to see the smoker and non-smoker. Will they have the newborn baby from smoker will have the lighter weight than the non-smoker. So then if you remember at the end, yeah, we do have our significant difference from the average. So after we simulate 25,000 times, then we have our empirical data. So then from the observed data, our difference, the newborn from smoker will be about 9 ounces less than the newborn with non-smoker. So then we find out that have the significant difference. So we favor our alternative. But the most important thing here is we just can say the conclusion for this example. We only can say from the observed data, we did see the smoker newborn baby weight is lighter than the newborn baby from non-smoker. But so that's only the association relationship we have. So remember at the end of the last lecture, we asked you, can we say the smoking caused the baby has lighter weight. Remember, we say we cannot conclude that. So then here we want to show you why also we cannot conclude that. So here is our table, right? So we just, according to the group, let's find the average for all the numerical data. So you can see here is the non-smoker. So yes, the baby weight is, for smoker, they are much lighter. But this one is not the only difference. You can see the pregnancy date actually is shorter. And the mom's average, the age average is younger for the smoker as well. So height, yeah, is higher. But the weight also for the mom, smoker weight is lighter than the non-smoker as well. So that's why you can see here, smoking is not the only reason possibly affect the baby weight. Because the sample data we get is the observed data. We see this sample, we kind of get the conclusion, but we only accept the alternative hypothesis. We say the baby weight from smoker is lighter than from non-smoker. That's the only conclusion we can have. We have that association. Okay, but if you want to do the causality, also when we say the causality, that you really have the reason and the result. If you really want to say that smoking is the reason cause the baby weight is lighter, this sample data is not good enough. Why? Because we don't know how the sample came from. For the smoker, baby, maybe their environment when during the pregnancy they have different other factors. That we don't know. Or you can see sometimes they have also the mom's age and mom's weight, so they may also affect the baby weight as well. So that's why here this we call, when we do the A/B testing, we can have our conclusion, but that conclusion is only the association relationship. So when you really want to go to our topic today, causality, it's not good enough. So according to the observed data, even we conclude some statistic difference or statistic significance, it's not quite enough to confirm the causality. Because the most important thing for causality, we need the random assignment. So what is the random assignment? We talked about that a little bit in week 2. So remember about the random assignment. We have our, if you remember, we have our control group and the treatment group. But no matter what, when we choose all the sample data, they need to be similar environment, a similar living environment or the behavior and everything. Remember our the London example, right? So that's why here, that's we call the random assignment. Okay, so when you want to have the causality relationship, doing the testing, we need to make sure our sample data came from the random assignment. So here is another example to show you how important the random assignment is. So this is just an example. They talk about, they find out all the app consumer spending money around the world. Okay, so here we have the iPhone app store and the Google Play. So then you can see every year on the iPhone, Apple, okay, so Apple app, they kind of consume more, they spend much more on the Apple app than the Google Play. Okay, so from here, the data we have, we will see from iPhone users spend 2 times as much as Android user on the third-party app. So is the higher spending caused by user owning an iPhone? So you see here, caused by. That's mean anyone have iPhone, they will spend more money on that. Okay, that's what we call the causality. Can we have that conclusion? Actually, we cannot have. Because one thing is, how we have the sample people have iPhone. Okay, it's not random. if you want to have that conclusion, you need to make sure you need to have a sample random people. Okay, so then you came from very random sample. So then you give them an iPhone, you give them an Android phone. So that's differences. So then you can do the testing. But in our example here, if we just get our result from the app usage, we cannot tell because users are not randomly assigned a phone, like earlier I said. And also you have other factors contribute to their phone purchase decision. Because iPhone is more expensive, it's maybe the people have higher income by purchase iPhone, so that's why they spend more. Okay, so that's the random assignment. So the next lecture we will talk about the causality.